Let's take a moment to explore the evolution of the .NET framework. Prior to .NET, we lived in a world with COM. COM allowed you to build classes and applications using VB6 or C++. Let's examine how we moved from COM and migrated all the way to the world of .NET 3.5. We'll do this by examining the typical layers when building your application architecture. These layers involve object management, data access, user interface, and then deployment. So starting from object management, back in 1997, we released Microsoft Transaction Server. This allowed you to take your objects and build declarative transactions and security around them, managing the objects and transactions without necessarily having to recompile your code. Going forward, we moved this into COM+. We renamed MTS to COM+ Application Server. Basically, it was the same thing with a few enhancements to allow you to work with COM+ applications. Going forward, when we released the .NET Framework 1.0, we wrapped COM+ Application Server in a managed layer. We called this layer Enterprise Services, and you can still find this under System.Enterprise Services with the .NET Framework 1.0, 1.1, and 2.0. Going forward in 3.0, we released Windows Communication Foundation. This allows you as a developer to combine COM+ Application Server, to build declarative transaction services, to do message queuing, to build web services, to do .NET remoting, all under a single unified namespace, which is WCF. So now, instead of making a choice when you're writing your code on how you want to expose your data, for example, if you know a .NET component is going to be calling your code, you might choose to use .NET remoting because it's binary and it's faster. However, what if your application needs to be called by a Java web service? As a developer, you're forced with either deciding to migrate your .NET remoting component to a web service, or you have to think about whether you want to build a separate DLL as a web service and manage that independently than your .NET component. This is no longer the case with WCF. How the message is transported is decided at runtime. So as a developer, all you need to do is worry about writing the business logic, and then whoever is calling your code can decide whether they want that data transported in a binary, serialized format, whether they want it over TCP/IP over port 80 or HTTP. We'll cover this in greater detail when we talk about Windows Communication Foundation. Let's talk about data access. In the COM days, there was ODBC, JDBC, and OLADB. The idea behind this was to provide a universal data adapter for any type of data access you were doing. In theory, this meant that should you ever change your database behind the scenes, you wouldn't have to worry about the driver. ODBC and OLADB provided a common denominator as a driver between various databases. That way, should you ever decide to go, let's say, from SQL to Oracle, you didn't have to worry about changing the driver. In practice, this wasn't necessarily as useful as it appeared in theory. No one really changes their database overnight. And keeping the driver the same, the time gained from that is really negligible. With .NET 1.0 and 1.1, we introduced the concept of managed providers. This means you have a specific provider based on the data source you're targeting. So if you're working with SQL Server, you'll work with the SQL Client Managed Provider. If you're working with XML, you'll work with the XML provider, Oracle, Oracle Client, etc. This way, you can take distinct advantage of what a particular data source has to offer you, instead of blurring the lines with a common denominator in a driver such as ODBC or OLADB. Going forward, this model remains unchanged in .NET 3.0 and 3.5. We do introduce a new programming model called links in .NET 3.5. Links doesn't change the data access behind the scenes, it just simply gives you a more productive way of writing your queries. Now let's talk about the user interface. We've come a long way since Windows Forms back in VB6. In the past, Windows Forms were black box constructs. They weren't classes, they weren't objects, and you really couldn't do much to manipulate the traditional behavior of a Windows form short of going into the Windows API. For web development, we introduced Active Server Pages, or ASP. Now we call these pages Classic ASP. The ASP programming model allowed you to develop dynamic web pages. Going forward, nothing really changed in COM+. However, when we got to the .NET Framework 1.0 and 1.1, we started introducing the concept of WinForms as objects. Now you are able to inherit the behavior of particular objects such as Windows Forms, buttons, and other controls on the Windows forms and work with them as is or change the behavior as you wished. In ASP.NET, we also introduced an object model, allowing you to build web forms much like you would do with Windows forms in an object-oriented fashion. Smart Client development was also popular at this time. We now call Smart Client applications rich interactive applications, but at this time, Smart Clients were a hybrid of using Windows Forms logics and ASP.NET logic, leveraging the power of the desktop in conjunction with the delivery of a web mechanism. The same model applied in .NET 2.0. With 3.0 and 3.5, we introduced some new user interface programming models, specifically Windows Presentation Foundation. For those of you looking to build rich interactive applications using vector-based graphics, WPF is the application model of choice. WPF allows you to build non-traditional three-dimensional objects using the user interface of a desktop. This user interface can also render in a browser using a subset of WPF called Silverlight. Silverlight allows you to target a variety of different browsers, giving a rich user experience without necessarily having to install the .NET framework. Going forward, ASP.NET still exists, with several enhancements such as ASP.NET Ajax, which combines the powerful client-side programming model with the traditional server-side model of ASP.NET. And lastly, with deployment. In the past, you would either have a setup executable or setup MSI that was deployed via CD or stored on a network share somewhere and installed by the user. With the advent of the web, we introduced the concept of no-touch deployment, allowing users to basically go to a website, click on a particular URL, and download an application as necessary. With the advent of Click 1 in 2.0 and going forward, we now provide you the ability to not only install the application, but have the application smart enough to know when updates are ready. You've probably seen Windows Update on your machine. This is very similar to the self-healing auto-updating model that we have in Click Once.